My name is Mahmood Rasheed. Today I'm going to present my final project presentation. My topic is Trojan classification using the visualization method. In this research project, I use the CNN algorithm. Just I would like to share my screen with you about my presentation. So that's uh, that's my topic. I hope you can see it on screen now. Yeah, that's my topic. The Trojan classification using the visualization method, in which I use the CNN algorithm, which is a more effective to detect the Trojans. As we know, there is a number of the cyber attacks, data breaches, and penetration was happening in past year. They badly affect all the industry of the enterprises and each department of the organization, which was connected to the computer. In my research project, I conclude there is a two method of the Trojan detections. One is a static analysis and second one is a dynamic analysis. In my research study, I conclude the static analysis, if we get the appropriate information without running the files, so that kind of analysis will be used. That analysis is called the static analysis. We run the file a particular environment. Dynamic analysis is a more productive as compared to the static analysis, because we run that particular file and up and a particular environment where we can get the appropriate information about the files and the data. When the hacker run the intelligent code, which can easily sense the information and manipulate that information that he has required for the bad intention, information it was stored in a that information is being stored in a hashes for hash form or any signature based form. So weakness of this method and static analysis and dynamic analysis are factor detection. It cannot work efficiently in a packet detections. That's the main weakness of the static and dynamic analysis. My research question is how much it will be the effective and efficient considering the CNN algorithm with the visualization being a Trojan. Here we can classify the data packet without unpacking the packets. CNN is a more efficient to classification of the Trojans by characteristic, as the static analysis and dynamic analysis is under our considerations. More efficient, we can classify the malicious in a CNN algorithm. We can easily classify the malicious data packets without unpacking the data. In research methodology, we prepare the data sets. Actually, I have one research work. First, I conclude the first data set that belong to the visualization algorithm, where I download the probably 2000 sample of the files that contain the exe file, which contain the exe file. We divide and subset of the samples into two parts, options and evolutions. After passing the algorithm, we will get the images with different dimensions. After passing the images through the CNN algorithm, then we choose 128 images sizes. If we increase the size, then machine learning requirement will be high. Resources you will need for 120 to 128 into 128 is a very light to run the resources. That's the reason we select the 128 resolution size of the resources. When we will receive the images, then CNN algorithm will train and test. Finally, we will pass through the evolution data sets to train the model. We check the CNN algorithms on a different exe files. In our visualization method, as we already discussed the algorithms for the channelization of the purpose of the algorithms, green channel contain the gray resources conversions, and red channel contain the particularly it's a particular of the files and a particular size of the file that is in the bytes, and blue channels contain the size of the files. Training and validation of the research question. This is the training and validation accuracy and training and visualization losses of the data. In this training method, we can getting the accuracy probably that is 95%. This is better accuracy as we channelize the model. Regarding to the evolution, this is the matrix based evolution that's based on the false to true negative and false positive and true positive as our trained model can be classified. UPEX, packed and zip files. In this research method, we use the OPEX and packed zip files. We believe that the CNN model is the one of the best model in which we can increase the efficiency of the model, as the data set are a data set which is provided to train the model. We provide some true positive and few false positive for malware or detection. We get some supporting evidence. It is possibly to using the naturalization, using the pack Trojan samples without the packet that we had, using to zip to compress to get this matrix. In our conclusion, we have checked our proposed model that work on our exe files. We are unable to detect the Trojan without unpacking samples. These could be malicious. If there are not a malicious, if any file or any exe file which is being used, if they are not malicious, then they will be buying. Here I left a question for the future work. The customs detection of the customer packet and its efficiency, because using CNN algorithms, so here will be it will not be much more effective in efficiency using the customer package. Now I am going to present my demo which I use for the classification of the Trojans. That's totally based on CNN algorithms. So just want to share my Actually, I have the code demo in Python. I use the Jupyter. We start using the required packing, importing the required package, that's a fill, math, and times. So PIL is for the imaging processing, and first what we will do in this, we will do this um, in this the data set. First we would like to take the images, and then we take the exe files. Here I select the WhatsApp exe file, which will be converted into the images that contain the convert the file into the images, because the code start to work. That's the code for the visualization, which is being to use to converting the exe file so into the images. These are the parameters, and which is calculating the bytes, and then is that's the width format of the of these files, and that code will convert the images exe file to the images, and then we will pass through the visualization algorithms for a single files. So that file is going to be stored on the user desktop. That's the location of my desktop. So that's a WhatsApp exe that allows a single file into the images, and we are using this particular path. That is the path, and I will take to two, probably that will take the, either I'm using the probably 7 MB of that's probably 6.7 MB file that is going to take probably is 7 minutes, 7 minutes time uh, to process. And for the multiple images, then we will pass those files to the CNN model, improving the required images. First, they will train the model, and then it will give the result. That's how we will. That's the code how we will convert the exe files, which is I have been taken from the WhatsApp.exe, and it has been converted into the images, into the image. For the single file conversion, images is here, and that is stored on my desktop. So I can show you. That's the path of that's the image which is going to use. So that's the path. That's the exe file of the WhatsApp, and that's the image of that the image which was converted into the exe file of the WhatsApp, that is converted to the image. That is the image which is appearing on my screen. And then I come back to the code again. Here we loading required packages, that's a MATLAB, PIL, and TensorFlow. So to perform the required work, so all the data, all the images that has been stored on the path and data set Mahmood data train. Probably I use here download probably samples images dimension are 128 to 128. These are the size of the images, which is and mean and another thing just I would like to share. I would like to discuss here with you. I select the batch size is 32. So and image height is 128 128. If we increase the batch size, the machine power need to increase in a model. We need a model RAM. So to increase the batch size, then we will increase the resources as well. I mean, the batch size is directly proportion, which is 32, 32, and if you increase the batch size, then you will need more resources. So we found 396 files and for the classification that's belong to the classes and 357 files for the training for that model. So here is the classification of the layer of the CNN model. So that have the dimensions is that 32 128 and 3. Now just I'm going to so these are the configuration model layers. That will be the accuracy. That is actually that's a train model which is going to take the output of the operations which is being to inform. We pass the data set into the evolution model as you said, have the file which is the zip files or the is exe file of the WhatsApp. It was converted into the images, and that model is going to these are the apples which is which size is 100. So here layer of the CNN model that we run the machine learning model. We have the 100 size of the apples. It will run the 100 times, and we will see if apples are increasing the accuracy in running. So with you can see here. So as we said, the apples is 100. So with the when it will be run 100 times. So when you will I mean it will be increased, then the efficiency gonna be increased here. So you can see here. And these are the that will be run 100 times. So checking the accuracy and losses of the model. So we use the JSON model to load the save and predicted first the data set, then we load the prediction, checking the file against the CNN algorithms. That probably give the efficiency more than 80%. So when we will run the evolution data set and will pass through the models. So if it is a bang, so that because the model is already trained, and it will give the message of the, if it is a malware, so then that will be give the message of the malware. Here we check that's the files we have stored in a data set, and after train model, when all these files are passed through the CNN model, so then it it will give the result. The same model prediction of the future use, that is the model, like that will be the predict about the files. So as 128 size the images, so that image is being stored on desktop on my location. So when all these files will pass through the CNN model, so that image is, if as passed through the CNN model, that gives that the WhatsApp WhatsApp.exe are being. So that's my demo, all about my demo. And as I have discussed, the image size is going to be going to use as 128, and that's a loading model that will be a predict when we will pass the store images, and then all the data set will pass to the CNN models. So these are the files which are is bang and malwares. These are the files which has been stored here. So the files, and I have already discussed with the POSIX. So that probably that's the accuracy and the losses. Like when we run the epochs for 100 times, so with the so that's the epoch is going to run 100 times. So when we will pass the data set to the epochs, so it will be, because we have set 100 times, 100 times frequency when we will pass, so we will increase the efficiency, and that is our required result, that the train model has detect when we pass through all these data set to the train, and then pass to the CNN algorithm, so that it is easily has been identified the WhatsApp.exe is a being. Thank you. Thank you very much for your listening.